Okay, so we've all seen AI get scary good at spitting out the right answer. But here's a thought. What if it's right, but for all the wrong reasons? Well, today, we're diving into a massive leap forward in AI. We're talking about teaching these machines not just what the answer is, but how to actually think their way to it.
I mean, it's a wild question, right? Can an AI stumble upon the right answer even if its logic is totally off? And it turns out the answer is a huge emphatic yes. And that, right there, points to a really deep-seated problem in how we've been training a lot of these AI models.
So for the longest time, the old way of doing things was basically giving the AI a cookie if it got the right answer. You know, you ask it a question, it says 42, the answer key says 42, and boom, it gets a reward. But here's the catch. We had no clue how it got to 42. Was it brilliant step-by-step logic, or did it just, guess? The whole process was a complete black box. And this quote just nails it. Correct answers don't guarantee correct reasoning. Think about it. In math class, you can't just write down the answer, you have to show your work. And it turns out, for AI to do anything really meaningful, especially in science, that same rule has to apply. The how is just as crucial as the what.
And this right answer only approach hits a total wall when you get to stuff like, say, proving a complex math theorem. I mean, with a theorem, the whole point is the proof, that rigorous step-by-step logical journey. You can't just skip to the end and say, ta-da! So for these kinds of problems, the old way was, well, a complete dead end. We absolutely needed a new way of thinking about this.
So, what's the solution? Well, it's a whole new paradigm, a complete shift in how we teach these things. It's all about teaching AI to check its own homework, to self-verify. And this new approach is called self-verifiable reasoning. The concept is actually pretty brilliant. Just imagine you have two AIs working together. One AI is like the star student, the generator, who's trying to solve a problem and write out the proof. But then there's a second AI, the verifier, who acts like the world's toughest professor, meticulously checking every single step for any logical flaws. So here's how it works. Step 1, the generator AI cooks up a mathematical proof. Step 2, the verifier AI comes in and scrutinizes every single line of that proof. Now here's the key part. Step 3, the generator only gets rewarded, only gets that cookie if the verifier signs off on the entire proof. No shortcuts, no lucky guesses. And the result? A proof that's logically solid and, most importantly, trustworthy.
But what's really, really clever here is how the system keeps improving. It's like a built-in arms race. To make sure the generator doesn't just learn how to trick the verifier, the system is constantly cooking up new, even harder problems for them to solve. This keeps the verifier on its toes and pushes the whole system to get smarter and smarter.
Okay, so you've got this amazing new method for teaching an AI how to reason. What happens when you actually build it and let it loose on some really hard problems? Well, you get a new math champion, and honestly, its skills are kind of mind-blowing. So this new method gave birth to a model called DeepSeq Math v2. And as the name suggests, it was built to tackle one of the toughest, purest forms of logic out there, advanced mathematics. And once it was trained up, it was time for the final exam. The researchers pitted against problems from some of the most insanely difficult math competitions on the planet, and the results are in. And wow, the results are just staggering. We're talking gold-level scores on problems from the International Mathematical Olympiad and the Chinese Mathematical Olympiad. These are competitions for the absolute best high school math geniuses in the world. And if that wasn't enough, it got a near-perfect score in the Putnam competition, which is legendary for being brutally difficult even for top university students. Let that sink in for a minute. 118 out of 120 on the Putnam, that is just unbelievable. This isn't just about being a good calculator. This shows a level of precision, a depth of reasoning that is genuinely a breakthrough moment for AI.
Okay, so it's a math genius? That's cool. But what does this mean for the future of reasoning itself? This is where things get really, really interesting.
Look, this is about way more than just solving math problems. What this really proves is that we finally have a path toward creating AI that can reason reliably. We can build systems that we can actually trust because we can follow their work, we can check their logic, and we know they're not just making things up. And that's the end game, right? The researchers themselves say this could have a massive impact on scientific research. Just imagine an AI that can tackle some of the biggest unsolved problems in science and math, one that generates novel proofs and ideas that human scientists can then verify, build on, and use to push the boundaries of our knowledge. So, this isn't just a new tool.
It's like opening a door to a whole new frontier of discovery. And it leaves us with one heck of a question to ponder. Now that we have AI that can truly reason, what unsolved problem, what great mystery of science will it help us crack first?